Welcome, students, to the captivating realm of physics, where curiosity meets discovery. As we embark on this intellectual journey, I encourage you to explore the wonders of the universe, from the smallest particles to the vast cosmos. I invite you to view our latest video, which delves deeper into this fascinating subject. Kindly subscribe to our channel for ongoing insights and discussions that will ignite your passion for learning. Together, let us uncover the mysteries of nature.
Dear students, in this video we are going to study about the sources of electromagnetic waves and also about the electromagnetic spectrum. Now, let us study about the sources of electromagnetic waves. Any stationary charge produces only an electric field. When the charge moves with uniform velocity, it produces a steady current which gives rise to a magnetic field which is not time dependent, only space dependent, around the conductor in which the charge flows. If the charged particle is accelerated, it produces magnetic field in addition to the electric field. Both electric and magnetic fields are time-varying fields. Since electromagnetic waves are transverse in nature, the direction of propagation of electromagnetic waves is perpendicular to the planes containing electric and magnetic field vectors. Any oscillatory motion is also an accelerated motion. So, when the charge oscillates about their mean position, it produces electromagnetic waves. Suppose the electromagnetic field in free space propagates along z direction, and if the electric field vector points along the x-axis, then the magnetic field vector will be mutually perpendicular to both electric field and the direction of propagation of a wave. So we get these equations for the electric field and magnetic field. Electric field, which is along the x-axis, is given by E naught sin kz minus omega t, and the magnetic field is given by By equal to B naught sin kz minus omega t. That is, E naught and B naught are the amplitudes of oscillating electric and magnetic field. K is a wave number, omega is the angular frequency of the wave, and K vector, unit vector, it is called as propagation vector. That denotes the direction of propagation of electromagnetic wave. So here in this case, the oscillating charges, which are the sources of electromagnetic waves, there will be an electric field and magnetic field which will be perpendicular to each other, and the direction of propagation is along this is the direction. So along the x-axis, the electric field varies, and along the y-axis, the magnetic field varies. Now, if both electric field and magnetic field oscillate with the frequency, which is called as the frequency of the electromagnetic wave, and that is equal to the frequency of the source, that is, the oscillating charge is a source for the production of electromagnetic waves. And in free space or in vacuum, the ratio between E naught and B naught is equal to the speed of electromagnetic wave and is equal to the rate of light, which is given by the rate of c. And c is given by E naught by mu naught. In any medium, the ratio of E naught and B naught is equal to the speed of electromagnetic wave in that medium. Thus, we get this expression for the velocity v, which is given by E naught by B naught, which is less than c. Further, the energy of electromagnetic waves comes from the energy of the oscillating charges. Now, we will study about the electromagnetic spectrum, which is given by this diagram, which is nothing but an orderly distribution of electromagnetic waves in terms of wavelength or frequency. So, in this wavelength band, what are the electromagnetic waves present? That is given by this picture. Let us first consider about the radio waves. They are produced by accelerated motion of charges in conducting wires. The frequency range is from a few hertz to 10 power 9 hertz, and they show reflection and diffraction also. They are used in radio and television communication systems and also in cellular phones to transmit voice communication in the ultra high frequency band. Then the microwaves. It is produced by special vacuum tubes such as piston, magnetron, and gun diode. The frequency range of microwaves is from 10 power 9 Hz to 10 power 11 Hz. These waves undergo reflection and can be polarized. It is used in radar system for aircraft navigation, speed of the vehicle, microwave oven for cooking, and very long distance wireless communication through satellites. Next is the infrared radiation. And this infrared radiation is produced by hot bodies, which is also known as heat waves, and also by the molecules which undergo rotational and vibrational transitions. What are the frequency range of infrared radiation? That is from 10 power 11 Hz to 4 into 10 power 14 Hz. And it provides electrical energy to satellites by means of solar cells. It is used to produce dehydrated fruits in greenhouses to keep the plants warm, heat therapy for muscular pain or sprain, TV remotes as a signal carrier, and it looks through haze, fog or mist, and used in night vision or infrared photography. Then comes the visible light. It is produced by incandescent bodies, and also it is radiated by excited atoms in gases. What's the frequency range of this visible light? It is from 4 in 10 power 14 Hz to 8 in 10 power 14 Hz. And this visible light obeys the laws of reflection and refraction. It undergoes interference, diffraction, and also can be polarized. It exhibits photoelectric effect also, and it can be used to study the structure of molecules, arrangement of electrons in external shells of atoms, and this causes the sensation of vision. Next comes ultraviolet radiation. It is produced by sun, arc, and ionized gases. What's the frequency range of this UV radiation? That's from 8 10 power 14 Hz to 10 power 17 Hz. Then it has less penetrating power, and it can be absorbed by atmospheric ozone and is harmful to human body. It is used to destroy bacteria in sterilizing the surgical instruments, burglar alarm, and to detect the invisible writing, fingerprints, and also in study of atomic structure. Next comes X-rays. It is produced when there is a sudden stopping of high-speed electrons at high atomic number target, and also by electronic transitions among the innermost orbits of atoms. What's the frequency range of X-rays? That is from 10 power 17 Hz to 10 power 19 Hz. X-rays have more penetrating power than ultraviolet radiation. The X-rays are used extensively in studying the structures of inner atomic electron shells and crystal structures. It is also used in detecting fractures, diseased organs, formation of bones and stones, observing the process of healing wounds. Also, further, in a finished metal product, it is also used to detect faults, cracks, flaws, and holes, which is called as non-destructive testing. Next comes gamma rays. It is produced by transitions of radioactive nuclei and decay of certain elementary particles. They produce chemical reactions on photographic plates, fluorescence, ionization, diffraction. What's the frequency range of these gamma rays? It's about 10 power 18 Hz and above. These gamma rays have higher penetrating power than X-rays and UV radiations, and it has no charge but harmful to human body. Gamma rays provide information about the structure of atomic nuclei. It is used in radiotherapy for the treatment of cancer and tumor, and also in food industry to kill pathogenic microorganisms grown.
Summary. Unit 5 Electromagnetic Waves. Pages 274 to 277 cover the fundamental properties and the classification of electromagnetic EM waves. The text explains that M waves are produced by accelerated charges and consist of oscillating electric and magnetic fields that are perpendicular to each other and to the direction of propagation. Key properties include their transverse nature, their ability to travel through a vacuum at the speed of light, c. approximately 3 times 10 to the power of 8 meter per second, and the fact that they carry both energy and momentum. The electromagnetic spectrum is detailed as an orderly distribution of these waves based on wavelength or frequency, ranging from long wavelength radio waves to high frequency gamma rays. Each type of radiation, including radio, micro, infrared, visible, ultraviolet, X-rays, and gamma rays, is identified by its specific production method and practical applications in technology, medicine, and communication. 10 multiple choice questions, MCQs. What is the velocity of electromagnetic waves in a vacuum? A. 3 times 10 to the power of 8 kilometer per second. B. 3 times 10 to the power of 8 meter per second, c. 3 times 10 caret 10 meter per second, d. 3 times 10 to the power of 6 meter per second. Answer B. Which of the following is not a property of electromagnetic waves? A. They are transverse in nature. B. They require a material medium for propagation. C. They carry energy and momentum. D. They are not deflected by electric or magnetic fields. Answer B. The ratio of the magnitude of the electric field, E, to the magnetic field, B, in an M wave is equal to A. The speed of light, c. B. The square of the speed of light, c squared, c. Permittivity, epsilon underscore 0. D. Permeability, mu underscore 0. Answer A. Electromagnetic waves are produced by A. A charge at rest, B. A charge moving with constant velocity, c. An accelerated charge, D. A neutral particle. Answer C. Which part of the electromagnetic spectrum is used in radar systems? A. Ultraviolet rays, B. Infrared rays, C. Microwaves, D. Gamma rays. Answer C. Heat waves is another name for which type of radiation? A. X-rays, B. Gamma rays, C. Visible light, D. Infrared radiation. Answer D. Which waves are used to study the crystal structure of solids? A. Radio waves, B. X-rays, C. Microwaves, D. Ultraviolet rays. Answer B. The wavelength range of visible light is approximately A. 400 nanometer to 700 nanometer, B. 1 nanometer to 100 nanometer, C. 1 m to 10 m, D. 10 caret minus 12 m to 10 caret minus 10 m. Answer A. Which radiation is used to kill bacteria in water purifiers? A. Infrared, B. Visible light, C. Ultraviolet, UV, D. Radio waves. Answer C. The highest frequency radiation in the electromagnetic spectrum is A. Radio waves, B. X-rays, C. Gamma rays, D. Ultraviolet rays. Answer C. 5 2-mark questions. Define electromagnetic waves. Electromagnetic waves are non-mechanical waves consisting of oscillating electric and magnetic fields that are perpendicular to each other and to the direction of propagation. State the transverse nature of electromagnetic waves. Electromagnetic waves are transverse because the oscillations of the electric and magnetic field vectors are perpendicular to the direction in which the wave travels. What is the electromagnetic spectrum? It is an orderly distribution of electromagnetic radiations according to their wavelength or frequency. Mention any two uses of infrared radiation. Infrared radiation is used to provide electrical energy to satellites via solar cells and is used in TV remote controls for signal transmission. Why are gamma rays used in medicine? Gamma rays are used in medicine for radiotherapy to kill cancer cells and for sterilizing medical equipment due to their high penetrating